7.2 is moving forward again. That's also kind of extending experience with our standard form of an exponential equation. If you remember that A was your starting amount, Y represents the total amount, A represents the starting amount, B represents the growth rate, X represents something typically like time. So that's actually here, right here. But again, A is your starting point, B is your growth rate, X is typically time, and Y is your total. So what we're going to do is take this to a new problem today that's going to force you to understand what all those things mean, because you're going to need this to actually figure something out. In the problems that you had before, they gave you A and B. In the problems today, they're going to give you Y, A, and X. And you're going to find B and then plug it back in. And you've done this before if you remember doing the Y equals MX plus B, where they gave you a Y equals an M and an X. And you had to go 7 equals 6 plus B and 1 equals B, and then you put Y equals 2X plus 1 or whatever it was when we did the equation of a line. This is the same thing except we're doing for exponential equations. So the problem of the day, again, jot down any extra things you need as you go. A population of people in a certain area grows from 125 to 600 in 4 years. Write a function to represent the growth. Find the population after 8 years. So I know that my formula is Y equals AB to the X. I know that A is my initial number, which is 125. I know that B is my growth rate. I don't really know my growth rate. It has to be a percentage, and I don't know what percentage I would use, even though you could try to take the 600 and 125, but that's not really your growth rate. That would be a percent change. So you don't really know that, so I'm just going to put a B there. X usually represents time, and they give me 8 years. So that leaves us another number here that we haven't dealt with. But remember that Y represents the total amount in the end, which means in this tricky problem that we have, that 600 goes over here. In other words, this tells me that we start off with 125, and 8 years later we had 600 people. So now I got to solve it. B needs to be alone. Exponents are stronger than multiplication, so I'll divide by 125, which gives me 4.8 equals B to the 8th. Keep in mind the opposite of exponents is root, so if I want to get rid of an 8th power, I use the 8th root. So 8 second caret 4.8 is 1 point. We want to go 2 digits, so 1.22 equals B. So what that means is a 22% increase. So just make sure that that answer makes sense. Don't have a decrease number here and it increases, and don't have a decrease here and that's an increase number there. So just check that does make sense. So what we do now is, first off, we write a function. So I'm sorry, that's not supposed to be 8. I'm tripping. It was 4. They wanted after 8, so we got to do that again. So 600 equals 125 times B to the 4th, which means we do have 4.8 equals 120 equals B to the 4th. Then we do the 4th root of both sides. Which is 1.48 equals B. Now we write the formula, which is Y equals your initial 125 times 1.48 to the X. That is your general formula. So let's go through that again. You don't know B, so you plug in Y, you plug in A, you plug in X. You use the algebra that we know to find B. We then plug B and A back into the function because that's your general formula. Now they want it in 8 years, so you plug in 8 for X, which is just going to be 125 times 1.48 to the 8th, which would be about 2877. This is your formula. I believe I'm going to make you write the formula. The second thing you're going to need is that number there. Make sure you check to see if you need decimals. But just to make sure, let's go ahead and see what the 4th power says, because this should be 4 years. 599.7, which is your 600, so it does work. You could always check it with that formula to make sure you did it right, because in 4 years it went to 600, and based off of this it says your population should be 600. So it is consistent. It is where it needs to be. But again, use those numbers to find b, plug b into your original formula with a and b only, using y and x as variables, then plug in whatever your new x is and go from there. The main focus of today's work is on solving equations with a variable in the exponent. There are a couple different levels of this type of problem, but we will start with the easy version. Consider the end game problem that we will see. So again, I like to teach in ways that help your brain to kind of recognize what's going on, and I don't want to confuse you first. I want to start with where we will end up. When we do our job, we will end up with something that looks like this: 3 to the x plus 2 equals 3 to the 5x minus 6. Well, if 3 to the something equals 3 to the something, the only number that it has to be is that those two numbers have to be the same. So whenever the base is the same, you can honestly ignore the base and focus on the variable. X moves over, 6 adds, 4 divides, 3 to the 2 plus 2 is 81, 3 to the 5 times 2 minus 6 is 81. So again, 2 works. That is your answer. But again, the key idea here is once you have the same base, even though we've never solved with a variable in the exponent, these are the easy ones we're seeing today, or the easy versions of what we're seeing today. Once the bases are the same, the bases don't matter because the exponents have to be the same. And that's the idea we're going to work off of. So hopefully you see how simple it can be. Now let's focus our attention on unwrapping the tricks. Again, they're just going to use tricks to make the simple problem look difficult. So what we're going to do is simplify this using a prime base. So if I had 2401 to the 6x plus 1, and I want a prime base, I need to find a number that goes into 2401. Well, obviously 2 doesn't. It needs to be a prime base. So 2401 doesn't, or 2401 can't be divided by 2. What about 3? Nope. 5. I knew better than that. 7. There it is. So 7 goes in to 343. I think you can divide by 7 again and divide by 7 again. That would be 1, 2, 3, 4, 7. So I believe 7 to the 4th is your 2401. So what we're going to do here is recognize that actually we've done this already. 2401 is equal to 7 to the 4th. So we take this and we parenthesize 7 to the 4th to the 6x plus 1. The difference is you have to remember that this, even though this is dropping down, you're actually distributing that 4. So it's 7 to the 24x plus 4. Just to prove it, 2401, let's put x equals 1 there. So 2401 to the 6 times 1 plus 1 equals that number. 7 to the 24 times 1 plus 4 equals same number. Again, if those two numbers match, which they do, that means that the facelift that I had was right. This is the number that you're trying to create. So again, take this number, substitute it, figure out what that number changes into, and just make sure you distribute it to both, because again, that is the step that makes everything work when you're doing what you're doing. A to the 4x minus 4 when a is equal to 27. That's easy. I think that's 3. 3 times 3 is 9 times 3 is 27. So 3 to the 3rd is 27, which means that when I get 27 to the 4x minus 4, 27 is going to turn to 3 to the 3rd to the 4x minus 4, which means I distribute that and get 3 to the 12x minus 12. That's all it is. All right. Not bad. Just something you got to make sure you're ready for. Simplify using the prime base again. So 1 over 16807 to the 2x minus 2. 16807. Don't worry about the fact that it's a fraction. We can fix that. Focus on that number there. So 16807 divided by 3. Nope. 16807. I'm pretty sure 5 is not it. 7 is another number. It is. And I remember 2401, so I think 7 to the 5th, because that was 7 to the 4th. So 7 to the 5th is your number. Now pay attention to this adjustment we have to be able to do when we learn to see. If 7 to the 5th is 16807, then we are looking at 7 to the negative 5th, because remember, a negative exponent moves the number down. And so we end up with 7 to the negative 10x plus 10. That's my power. That's all it is. But again, that's something you got to make sure you practice. Once you get it down, everything is easy enough to do. Just make sure, again, you are focusing on the number. That fraction shouldn't throw you off. Just focus on the 16,807 first, and then everything else will fall into place. 8, I believe, is 2 times 2 times 2, just from doing what I'm doing. So 2 to the third. If 8 is in a fraction, we're talking about 2 to the negative third. So we would turn this into, instead of 1/8, so 2x plus 8, it would turn to 2 to the negative third to 2x plus 8, which is 2 to the negative 6x minus 24. So again, make sure you practice that. Make sure you get what you need out of that. That is important, because if you can't do this process, but you can solve, then you're telling me something on your quiz or test. Because the only way you can solve these is to make the same base. So if you remember, I said in the end our base will be the same, but I said that it was going to just try to trick you. Well, here's your trick. We don't know how to get to that x. There's no algebra that gets me up to that x, but 9 and 27 are both divisible by 3. So this is 3 to the negative second. How do I know that? Because 3 to the second is 9, and the negative is going to put the 9 on the bottom. I'm going to convert this off to the side. 27 is 3 to the third, so 3 to the third to 3x minus 3 is 3 to the 9x minus 9. So again, 1/9 is 3 to the negative second. 27 is 3 to the third. Going to that leaves me with 9x minus 9. And now that my bases are the same, we take it back to the level of what I showed you first, which is negative 2 equals 9x minus 9. Adding 9 makes that 7 equals 9x. Dividing by 9, 7/9 equals x. There you go. So let's see. 27 to the 3 times 7/9. I hope this works. It'd be embarrassing if it didn't. Minus 3, which is 1/9. There you go. But the whole thing is based off of, can you rename these two with the same base? Once you get the same base, the problem is easy. It's just getting to that point and making sure you know that that's the strategy. 2401 to the 7 or to the x plus 4, 7 to the 2x plus 3. The good news about these right now is that these are quote unquote easy, which means that this is probably a power of 7, which we know it is. I believe it's 7 to the 4th, as experience has shown me. So this becomes 7 to the 4th going to the x plus 4, which means that this is 7 to the 4x plus 16. Again, that turns into 7 to the 4th. X plus 4 getting distributed gives me that number, equals 7 to the 2x plus 3. Now that I have my same base, I ignore it and solve. Subtracting 2, subtracting 16, dividing by 2. There you go. And I'll even check it just to make sure. 2401 to the negative 13 halves, that's negative 6.5. I'm just going to use negative 6.5 since it's easier to type into. Equals that number. 7 to the negative 6.5, I'm sorry, 2 times negative 6.5 plus 3 is, of course, that's how that works. So what did I do? This is 7 to the 4th. That is 7, 2x plus 3. That moved over there, made 16. That moved over there, made 13. 16 over 13 over 2 was right. 4, 16. Oh, you probably saw that a while ago. That's still not it. 7 to the 2x plus, I am messing up. I don't know. 7 to the 2 times negative 13 over 2 plus 3. 2401 to the negative 13 over 2 plus 4 equals, there you go. I must have typed the first one in wrong, which again, you were probably aware of that. But bottom line, make the two bases match, everything's easy. It looks complex, but again, this is the easy version of it. Just make sure you practice. The biggest focus for you to practice on is making sure you know how to rename your fractions, which we should know from the last chapter because we had to do it before. The focus of these problems is to, again, see the simplicity. After you can envision what the problem will look like, it helps you to focus on what's necessary to make it manageable. What base do I need? How do I change the numbers into what they're supposed to be? And remember that I do not lie to you about your expectations. There will be a type of problem where the bases are not the same coming up in the future. But as long as you work to stay disciplined with the lessons, I will show you what you need by the time that problem pops up. So be sure again to let me know when you need assistance. Send me a picture of your work to make the interaction more efficient. Think about this sequence, which I get all the time. Someone sends me an email with only an explanation of how they're having issues. So they just say, I'm having issues with 6.2. And my first thought is, I have no clue what's in 6.2, because you have to remember that I'm teaching you 6.2 while teaching 135 students 7.1, while teaching 134 students chapter 3.5. So I don't know what these problems look like. You need to just, like, the first thing I'm going to tell you when you send me that is, I'm going to say send an email with the picture. And then you send me a picture, and I do exactly what I told you to do in the beginning. So when you send your email, I'm not trying to sound cold, but time is precious. If you want to save time, I don't even need the explanation. Just say, I'm having issues with this, show me your work. We can talk about it beyond that, but I'd rather have you send me a brief explanation with the picture than a long explanation with no picture, because all I'm going to do when I read your long explanation is think the whole time, well, where is the thing that I'm supposed to be looking at? Because I can't do, mind reading things over the course of email or text. So show me what you're doing. I will look at it and I will analyze it and try to figure out what's going on. But other than that, good luck and have a good day.